you, Nicolas and Martinez, for the invitation. It is an honor to be here and to share with the audience what we are doing in Paraguay about the aerospace development in general, and in particular now in Earth observation applications. I share my screen. Can you confirm that is on?
Yes, I confirm that we can see it. The stage is yours.
Oh, perfect. Thank you. Let me start my timer. Well, the Paraguayan Space Agency is a new space agency. We have 5 years of life. And in 5 years, we started to develop our aerospace sector in 2 lines, like we will see in a moment, especially in the Earth observation applications and in basic space systems engineering. First of all, let me start with some numbers. We know that the space sector is a huge market, is a huge opportunity for any countries in the world, especially on emerging countries. We are talking about more than $400 billion a year. And even the ratio of nanosatellite launches are experiencing exponential growth. The region of Latin America and the Caribbean just have 1.6% of that participation, and this is a huge room for improvement. The Paraguay Space Agency was created with the main objective to promote and manage the development of national space activity. Our annual budget is about $500,000 a year on average, and it remains stable in this initial 5 years of life of the space agency. We have our first infrastructure, a monitor and mission control center, a geo lab and space lab that we will be talking about in a few moments. And our main achievement was the launch of our first satellite and Earth observation applications. We have 4 pillars of development. The first one is to contribute to aerospace development in the public and private sectors. The second one is capacity building. The third one is related to the infrastructure that we need to build in order to develop our country in the sector. And the fourth one is the whole system needs to be sustainable. Right now, we are focusing in this number 2, these capacity building activities. Our main challenges, I think, is the same major or minor percentage in other countries, the resources. We need to be very creative in order to find and mobilize those resources in order to implement our plans and projects. And the need for capacity building. We are working with many institutions, international organizations, allied space agencies to implement our projects in the country. We are living in a changing world. We have many challenges in a planetary basis and also in the country basis. The pandemic changes everything. The way we work, the way we study, the way we communicate, and also the climate change is affecting everywhere. In order to take better decisions, to make better decisions, we need to understand the case of disaster, understand the disaster, the environment, and to read the data, the satellite data, we need to have a trained team. The satellite is producing 24 hours a day, 7 days a week, and 365 days a year data. And we are pretty sure that even 10% of the data is being used right now. The other 90% maybe it doesn't have a direct use at the moment. That is why we need to train our researchers, our students, the people who works in the space agency to to know how to download the data, how to find the data, then how to download it, how to process the data, and how to extract the better information to the decision-making process in the higher level on the government here in Paraguay. We are working with many institutions, and we are part of the International Charter for Space and Major Disaster as an authorized user. We do not produce yet information for them, but we are using in case of necessity, and I will explain two cases in my country the last 3 years. Well, as I mentioned, there are a huge amount of data available. We need to find a way to understand and to extract the value information from that asset that is in the tip of our hand. Is open and free data mostly. Then why develop space science and technology in any country? First of all, telecommunications. Second, Earth observation application, GNSS, position, timing, and navigation services, microgravity, and of course, observation and exploration of the universe. We selected Earth observation applications and basic space engineering projects. And also, we are very aware that aerospace science and technology generates productive transformation and accelerates the scientific, technological, industrial, commercial, and social development of any country. And I insist, especially on emerging countries like Paraguay. Then the Paraguayan Space Agency, as I mentioned, selected 2 lines of development. First line is Earth observation applications, and second line is space engineering. Both of them based on a strong capacity building component. All this frame is accelerated by the international cooperation, and we are making huge efforts on outreach in every level, even from children in the schools until the decision makers in the ministries and other institutions in our country. We have a strong international presence. In 5 years, we are part of many institutions and organizations around the world. In Earth observation application, we started with emergencies. In 2019, we have a huge flood here in Paraguay, affecting more than 100,000 families that were displaced. This was a huge problem, and the government declares a state of emergency. The Paraguayan Space Agency contributes to improve the decision-making process in this area, activating the International Charter for Space and Major Disasters. That is an organization that gathers almost 20 space agencies who jointly provide information in case of these kind of events. After the floodings, in the same year, after the first activation of the charter, we started with wildfires the same year. And again, we activate for a second time the International Charter for Space and Major Disasters. And let me add in this point that in that moment, the Paraguayan Space Agency doesn't have a single space asset and a single infrastructure for data processing. Even though this situation, we, thanks to the international cooperation, managed to provide more than 200 value-added products to the National Emergency Secretariat. And we are working with many institutions that includes the academia, other governmental institutions, and non-governmental institutions like WWF. And we created a unified report with about 9 institutions jointly collaborating with this initiative. And also this means a coordinating effort in the response, because we know that the event of fires, for example, not only affect the wildlife and the forest, but also the quality of air on the cities. This was our first experience, and we repeat every year the yearly fire monitoring season. Those are the space agencies that jointly provide information without any cost to, in this case, the Paraguayan Space Agency. With this experience, we created a GeoLab. The GeoLab is part of many other network of laboratories. We are part also of the AmeriGeo, that is a regional branch of GEO, the group of Earth observations with the main office is in Geneva, Switzerland. We are part also of the network of laboratories of Earth observation of Latin America for disaster reduction and other institutions. This is our first infrastructure. This is our GeoLab with the monitoring center here in Asunción. And we have another GeoLab jointly with one major university here, the Catholic University of in Asunción, where we are doing a training course for students, for public institutions, giving them the basic tool to start to use Earth observation applications and geospatial data to decision-making process. The team of the GeoLab, we are 6 people now. Most of them are trainees and interns from national universities in Paraguay. And we, with the help of these students and other colleagues from other public institutions, we created a yearbook with more than 150 thematic maps on the 2022, in the first year of the GeoLab. We are strengthening our capacity building with many open and free training courses with NASA, RCET program, ESA program, Copernicus program, and other. We are actively searching training opportunities, and we select the training that is relevant for us. And we all do that on the regular basis. The products of the GeoLab, some of them, this is for fires. This is fires analysis, NBR, burned area analysis. This is a land use change analysis. We can see a multi-temporal series of maps that you can see the loss of the forest and the recuperation of the forest in some occasions. And in other occasions, you have land use change. And then the forest became crop. You can see the logos of the data providers on the down part of the maps. These are just examples of the kind of analysis that our colleagues here in the GeoLab are doing. This is a floodings. This is now, it's January 2023. You can see in false color the river in red in the middle of the screen. And in 2 months, we have this difference between January and March, sorry. You can see the difference and the volume of water in this specific area in the city named Concepcion here in Paraguay. And also we are making analysis of NDVI, NDWI, and other kind of analysis. This is some products from the charter. This is a capital city, Asunción. And another city in Paraguay named Pilar. We have also analysis on the land planning and land management. And this is also on wildfires. And let me speak a little bit about our space engineering projects, because there are some lines of this project that is related to Earth observation also. The first Paraguayan satellite was launched thanks to the Paraguay to Space project. That is our first step in space, our first mission. And it's as a result of a cooperation with the government of Japan. We have made an agreement with the Kyushu Institute of Technology in Kyushu, Japan, and we selected a CubeSat as a mission. Why CubeSat? Because of the cost. This is the first. A second one is because it's an international standard, and it's very simple way to give the first steps in space grade technology. We started with one U CubeSat, and we now are working in the second Paraguayan CubeSat that will be a 3U CubeSat. Those are our first colleagues that went to Japan, one for PhD in space science and space engineering, and the second one for master degree in Kyushu. They successfully complete their academic program. From March to September 2019, we went from design to engineering model. This is the laboratory in Japan where our colleagues were working about 4 years. From September 2019 to February 2020, we complete the flight model, and we arrived to the launch. 2, 1. This was a historical moment for Paraguay because 3 million people in a 7 million people country follows this launch. This outreach as outreach activity is a huge.
The SS Katherine Johnson takes flight on this, the 59th anniversary of John Glenn's Mercury flight, carrying 8,000 pounds of cargo to the International Space Station. Good performance on the first stage so far.
Almost half of the population was following. This was an historic moment, and we are all proud of this moment here in Paraguay. 2 days after the launch, we reached the International Space Station, and on 14th of March, we put the satellite on orbit that lives about 16 months. We have an operation of 16 months. The space segment was 3 satellites, is exactly the same from 3 countries, from Japan, Philippines, and Paraguay. Those are some of the components. I will not go into details because of the time, but let me speak about two missions. One of them is the CAM mission. It's a low resolution Earth observation camera just for technology demonstration and outreach purposes, not operational. It's a COTS camera, 5 megapixels, nothing operational. And also one of the main missions was we selected public health problem in Paraguay. We have a bug that transmits a disease in the vulnerable areas. We put a trap on the field, and this trap detects the entrance of the bug on inside. We have a pheromone that attracts the bug, the female pheromone, and when the bugs go in, the sensors detect and they communicate each other in the wireless way. And they communicate to the hub, and from the hub to the satellite, and from the satellite goes down to the National University ground station that is from AP also. And we map the presence of the bug. We send this information for the authorities for countermeasure purposes. We have some images in low resolution, like I mentioned. Those are some examples of the images taken by the constellation of satellites. And let me speak a little bit about this image on the right. This image is one of the rivers of Paraguay, and it was a lucky shot because the sun reflects exactly in the way we clearly see the river. For us, it was a very lucky shot, and it's a beautiful images in the south part of the Paraguayan country. We learned a lot in this first year of operation. We have a 250-page final report of the project, where is everything inside from the design until the results. We went through all the tests in order to develop the satellite. And we work also with other satellites in the Kyushu Institute of Technology. This knowledge come back to Paraguay, and now we are working to multiply this knowledge here in our country. Those are the assembly processing in Japan that our colleagues went there, do when they are in the academic program. Those are some of the tests that every satellite needs to complete in order to be launched. This vibration and other kind of tests. I have a video here of the vibration test. You can see how stressful is the launch for the satellite, and we need to test the exact vibration that they will have in the launch, in the minutes of launch. We will see the starting of the test. This gives us a safety review in order to qualify the satellite to fly to space. Well, in the ground segment, we can explain a little bit more about the Chagas disease. It is an endemic disease in the region, not only in Paraguay, but the whole region. More than 100 million people is at risk. 7 million is infected right now. And we have about 56,000 new cases per year and more than 12,000 deaths. And the worst thing about this disease is it has no cure. We just can work on the prevention. And this is the back that transmit the disease. This is schematic of the trap. We have some entrances, and the detection is made by photosensors. And we have a pheromone that attracts the bug, and a wireless communication system. This is the location of the country where this project is on site, and all the project is powered by solar panels. This schematic on how we how we put the traps in the community. It's an indigenous community. And also for analyzing the data and for operating our satellite, we developed our first infrastructure, our operation center, 2 ground stations. This is the operation center in the National University. Some part of the team, the building process of the ground station. This is the indigenous community. It's a very vulnerable community. Imagine one of the main challenges of this project was, imagine to explain in a public assembly in an indigenous community a space program, and how and why the space program can benefit the indigenous community. In order to complete the mission, we send many people to Japan to have the training in not only in the grounds, in the space segment, but also in the ground segment. You can see here at the left the photo of one of the assemblies with the indigenous people, where we are explaining the project. This is the location of the sensors. And we are part of a network of Earth ground stations with other 13 countries around the world. We have a very good results with our ground station. We won a competition of ground station in this BERS family. And also we have a very good reception of the transmission with our 3 satellites of the constellation. This is some of the collected data. And this is the statistics of which one of the traps has more detections over time. This is a moment where the president of the Kyushu Institute of Technology delivers the satellite model to our ambassador, Paraguayan ambassador in Japan. Those are the certificates that accepts the Guaranisat-1, our first satellite, as a feasible payload to the International Space Station, and this is the certificate of the successful deployment from the International Space Station. Those are the institutions involved locally and internationally. We are very thankful for all the help and support they provide us, and all of them makes our first satellite a reality. The satellite ends the mission in July 3rd on 2022. And with the learning of the satellite, we create a space lab. The Space Lab is developing our next projects. We worked with other project, a Japanese mission that named Kitsune that yesterday re-entered and ends the mission also. And we are working on the Guaranisat-2. It will be a 3U satellite with the payload of Earth observation. We are making a lot of effort, like I mentioned, in training, international presence, and outreach. We are constantly training our staff. We are participating very strongly in international organizations like GEO, AmeriGeo, UNSPIDER, with Copius in UNOSA. On the IAF, Paraguay is chair of one of the committees, the Administrative Committee for Connecting Emerging Space Ecosystems, and also in the International Academy of Astronautics. We have very good relationship with many space agencies like NASA. The Paraguayan Space Agency is a partner for the 3rd year in a row of the NASA Space App Challenge. It's the biggest hackathon in the world. Last year, Paraguayan young professional win in one category on this in this hackathon with more than 30,000 participants around the world. We organize. This is an Earth observation event, one of the most important Earth observation event in America, in Latin America. We organized for the first time last year in Paraguay. The name is AmeriGeo, and we have the presence of many representatives and experts from around the world in person in Paraguay, in the university in Paraguay, and we share this knowledge with the students, the government representatives. And I'm finishing with this. We have more than 70 agreements with national and international institutions. And shaping the future, we are looking for new alliances, new challenges, and new projects. In conclusion, we have two laboratories working on the 2 lines of development of the Paraguayan Space Agency. And in 5 years, we were able to join the main international forums on space. We participated on the most important events around the world about space, and we are working with the most important space agency in the world. I want to finish with this. Together, ordinary people can achieve extraordinary results. Thank you very much, and I'm happy to have your questions.
Amazing, Alejandro, and I'll love the quote at the end that you included. Definitely, collaboration is the key towards success together. So we still got a minute. So I will ask you just one question, Alejandro. So what would be, based on the journey and experience that, again, you and your agency have had, what would be some of the advices that you would give other emerging space nations and the governmental programs?
Oh, fantastic question. I can resume in one phrase: never give up. Never, never, ever give up.
Powerful.
Keep working. Keep working. Keep trying. Keep in any moment you will achieve your goals. Never, never give up.
Amazing. Very powerful. All right. So Alejandro, thank you again for the presentation and for this, again, quote and this powerful insight that at the end, again, you provided. So we'll be happy to see you again next year, obviously, and we'll stay in touch and catch up before that even. So it was great having you, Alejandro.
Thank you very much, Nicholas.